Okay, domain is the x values, range is the y values. For a function, we're going to be identifying whether it is or it's not a function. So we're going to be answering whether it's yes or no. This may sound familiar. For every x, there is only one y. That is the way to determine whether something is a function or not, and we'll be looking at what that looks like. And then here we're going to use a vertical line test on a graph to determine whether a function is a function or not. So an example, first example, state the domain and range of this function, and it gives us a bunch of points. So the domain is all the x values, so what we're going to do for a domain is just list out all the x values. And in these coordinates, just listing -3, 5, 7, and -1. And then for range, same idea, but now listing all the y values. So in these coordinates, I have 4, 0, and then the y is the same in both of those, so we're just going to put 9 once. Okay, now it says determine if the following are functions, and it gives us a list of points. What we're looking for is this. For each x, there is only one y. So I'm actually going to show you the non-example first. So when I look at number 3, I have 6. If you put in 6, you get out -2. Put in 7, you get out 9. Put in 6, you get out -3. That can't happen. When you have the same x, you should always get the same output. Since they're getting different outputs here, this cannot happen. You can't get a different output, so this is not a function. And now looking at the other examples, I'm looking to see if there's a repeated x, because then I can identify whether I'm getting the same output. And here, the x's don't repeat. So yes, this is a function. And for number 4, again, looking to see if my x's repeat. They don't repeat at all, so yes, it is a function. For this one, I have the 4 repeats. So I have a 4 in the x position here and a 4 here. As long as it has the same output, look at the output's 5 both times, that is okay. So yes, it is a function. If I got a different output, then it wouldn't be. Yes, or
what if it's different x but the same y?
I actually have that example planned. I'm going to write it in a second. Or different x, that's fine. Different x but same y, that's okay. 6. So here, all different x's, so yes, this is a function. And then the other example that I was going to add is something like this. 1, 7, 2, 7, 3, 7, 4, 7. So I told you to look at the x's, and that still holds true. For every x, there can only be one y. In this case, yes, this is still a function. The y's repeat, but that's okay. If I had an x repeat and then it had a different output than the original, then that would not be okay. But this is fine. Okay, now we're going to be looking at the graph over here to determine if these are a function. The vertical line test is if we can draw a line and it only crosses at one point, then it is a function. So drawing a line anywhere on this, it should only cross at one point. And here it does. And so yes, this is a function. And then for 8, I draw my line and it crosses at 2 points. That means it's not a function. Okay, now next concept, we're dealing with function notation. f of x replaces y. The independent variable is x and dependent variable is y because it depends on what you put in for x. Given this function, g of x equals 3x squared minus 4x plus 10, find each value. So for this, we're going to plug in -2 for the x. So this is what it would look like. G of -2 equals 2 squared minus 4 times -2 plus 10. So all I did was I plugged in this -2 for all the x's in that equation. Okay, then from here, we're just going to solve, use order of operations, so -2 squared would be +4. Bring everything down. -4 times -2 would be +8 plus 10. So g of -2 equals 30, and that's my answer. Okay, for number 10, g of 3m. So for this, we're going to plug in 3m for x. So I'm going to start it up here to give myself more room. G of 3m equals Then from here, I simplify it as much as I can. Starting with this square, when you have something like this with the square on the outside, you have to square each of those numbers on the inside. So it'll look like this. 3 squared would be 9m squared minus 12m plus 10. 3 times 9m squared would be 27m squared. So g of 3m, and this is the answer here. And that's simplified as much as I can get it. Yes. Can you wait if I remember? Okay, slope, ratio of vertical change to horizontal change. We've all heard of slope before at this point. It's rise over run. That's if we're looking at a graph. We can just count the rise over run. Here's the equation. So if we're given points, we can use this equation. You could also obviously graph the points and then find rise over run. It's up to you. But we're going to be looking at both ways over on the next page. So moving over here. These are what graphs might look like. This probably looks familiar to you. A positive slope goes up and to the right. And then when you're looking at slope, that would be a positive number. The slope might be 4. It might be positive 3/2. A positive slope would be a positive number for slope. A negative slope goes down and to the right, and you're looking at a negative slope like -1/2 or -3. Those would be examples of negative slopes. Zero slope looks like this. It's just a horizontal line. That's like no change over time. So if a car is sitting still, time is changing, but the car is staying in one spot. The fraction for this would be like 0/2. Just no change over time. Then undefined slope, that looks like this. 0 over, wait, sorry, I did that backwards. It would be like a number over 0. You can't divide by 0. So that is called undefined, and the graph would look like this. It doesn't even make sense. Examples, find the slope between each pair of points. So they gave us points, now we have to use the equation. slope equals y2 minus y1 over x2 minus x1. The change in y is over the change in x. Yes, Harut?
How did you get negative half minus 3?
Oh, it was just an example of negative slopes. They're separate. Like negative 1/2 would be an example of a negative slope. Negative 3 would be an example. If you have a negative slope, your graph's going to go down and to the right. Here's the equation for slope if you're given 2 points. These 2 points would be x1, y1, x2, y2. And then we will plug them into the equation. So y2 would be 12 minus negative 3 over 15 minus 9. Yes.
So does an undefined slope not have a slope then?
Correct. Yeah. So it's a vertical line. Number 12, again, just finding slope between 2 points. This would be x1, y1, x2, y2. Find the difference in the y's over the difference in the x's. Equals 11. Up until this point, this should be pretty familiar. You've seen it before. Maybe it wasn't top of mind or you kind of forgot it. 13 and 14, we're finding slope from the line. So we're looking for rise over run. What's nice is they identified points of intersection here. So we're just going to go up 1 over 2. So our slope would be up 1 over 2, 1/2. Again, it's going up and to the right, so we're looking for a positive slope, which it is. 14. From one point to the next, rise over run going down and over. It goes down 1, 2, 3, 4, 5. So negative 5 and over 1, 2, 3, 4. So negative 5 over 4 is our slope here. Now 13 is what you may not have seen before, but it just builds on what we've been doing. Interval notation is a way to represent the domain and range from a number line or coordinate plane graph using brackets or parentheses. Parentheses here means less than or greater than, and this would also be an open circle when the circle's open. And then the brackets is when it's less than or equal to or greater than or equal to, and that would be a closed dot or closed circle. Closed dot. So open circle looks like this, the closed dot is shaded in. Another thing to note is that when you have x is greater than 2, it's written as 2 to infinity, and infinity must use parentheses, not the brackets. And we'll get to that in these examples. Okay, so they're giving you the graph. It says, give the domain and range in interval notation of each graph. Okay, so domain is our x's. We're looking for the lowest x, which in this case is at 0. It's a closed dot, so we're using the bracket. And then the largest x here is at 7. Again, a closed dot, so using the bracket. Yes?
So how'd you get 0 and 7?
Looking at this, I'm looking for the lowest x value it could be, which is 0, and the highest x value. And then I'm going to do the same thing for range, which will be like the up and down. Actually, I'd put a note here. Domain is your x values, so it's from left to right. And range is your y values, so it's bottom to top or up and down. So here, range is the y values. The lowest y value is right here at -2. If it's just that line meets -2, we use the bracket. And then the top one is at 4, using the bracket again.
Why do you use a bracket?
Because the line touches the number. That's all I can tell you. Because the line touches a number. It would include that value. And then 16, it shows the open dot. So that's going to be our parentheses at -5. And then the x value for this way is at 1, 2, 4. And it's a closed dot, so I know this looks weird, but we use the bracket over here. So parentheses right here. And then the bracket on the other side.
It doesn't touch 4.
It does touch 4. Why, you don't think it does?
Because it doesn't touch 5.
1, 2, 3, 4. I think it touches it.
Okay, so it's like a little bit off of 5. Negative.
What do you mean negative? Oh, here? Yeah, it's saying like
Oh, okay.
anything to the right of -5. So it could be like -4.9999999. It just doesn't include -5. Yes, right.
I'm still confused on how you got -2 and 4.
What? Okay. So this goes down to what about it don't you get?
Like, how'd you get it?
I'm looking at the y, so the lowest y value. So essentially, like this axis, the furthest it goes down is -2, and the highest it goes up is 4.
So always when writing brackets, you have to write like a smaller number first.
Yes. Okay, so for range, we're looking at the y now. Lowest y is at -2. It's an open dot, so we're using the parentheses. And then the highest y value is at 3, and we got a closed dot, so we're using a bracket. Bringing in more what ifs. See how this goes forever and ever? It's an arrow. That'll keep going further and further out. So therefore your x values are from -infinity to infinity and beyond.
Why is it infinity?
Because it would go forever and ever because you have that arrow. It would just keep going down and further out. Like your x's would be all numbers. Then range is your y. The lowest number is going to go down forever. So your lowest number is -infinity. Did you use infinity at all in Algebra 1? Have you been waiting for this moment your whole life? There's lots of infinities in calculus too. And then as far as the top y value, it's at 4 with the bracket.
Why does that one get bracket?
Because it touches the line 4.
What does the bracket mean again?
It means it includes that number. It could be equal to 4. Does that make sense? Okay. The next one, domain, is your x values. So you're looking for your x value furthest to the left, and that's at -1. It's a closed dot. And then in the other direction, this goes on and on forever, and it'll keep going further out. So this is infinity with the parentheses. Then your y values. Right here, the lowest y value is -3. and then it goes up forever and ever, so you're going up to infinity and beyond again. And that's all for the lesson today. You will have homework on Schoology for this. It's only 5 questions this time. You're going to be looking for 4 out of 5 questions correct for full credit, or 8 out of 10. Something I also want to bring up, there's these questions that look like this. This may be familiar, where the 2 boxes. So these questions are on your Schoology homework, where it has domain and range. So domain would be like your x's, maybe 1, 2, 3, and then your range is like 16, 17, 18, and then it'll have arrows, your input, output, input, output, input, output. That would be a 1-to-1. Sometimes you get something like this, where 1 can be 16 and 1 can be 17. That would not be a function, because for every x you can only have 1 y, not 2 different y's. But something that can happen is you could have 2 x's equal the same thing. For example, 1 the output 16, 2 the output 16, and then 3 the output 17. This would still be a function. It wouldn't be 1-to-1, it would be onto. So that's something to look for in the answer choices. Okay, if you have questions on your homework, let me know. But it's mostly like the function tests, some of this, and that's pretty much what the homework is. So go ahead and get your phones, get started on the homework. If you have questions, let me know.